Which values of current and resistance will produce a rate of energy transfer of 16 joules per second? Alright, so we need to figure out the values of resistance and current so that the energy transfer. Uh, Alright, so when there is a current, alright, so what is the current? Current is is the flow of electrons, right? So electrons are like flowing, for example, in this direction, alright? So electrons are flowing, and whenever electrons encounter some sort of resistance in a wire, what actually happens? The kinetic energy of these electrons is being converted into heat energy. Why? Because resistance is encountered by electrons, and they're resisting, and it is resisting the motion of electrons. So they have to put some extra energy, or the energy they have is wasted in, or actually converted in the heat energy. So the energy transfer that is going on over there is kinetic energy of electrons is being converted into heat energy, right? Heat energy. All right. So now we know that electrons are flowing, that is the flow of current, and electrons are encountering the resistance in the wire, and that resistance is actually changing the kinetic energy of electron into heat energy. So we need to find, that's the background of the concept, right? Now we need to figure out which combination of current and resistance is actually going to produce the energy transfer. Which energy transfer? We already have discussed that, of 16 joules per second, which means 16 joules per second. In 1 second, it's like in 1 second, in 16 joules of kinetic energy is converted into heat energy, and this is actually, we normally call it power. Okay, power is the rate of conversion of energy. So this is the power, and you know that watt is represented. What is the unit of power? And if you break down watt, it becomes joules per second. So 16 joules per second, we actually want that. And remember that we need to know the relation between the power and the current and the resistance. All right. So the relation between power dissipated in the circuit, the energy actually converted into heat, and the power is equals to I square. I is representing the current square times the resistance, right? So I square R is what representing the power, or the rate of conversion of electrical energy to heat energy. This is, by the way, the power dissipated in the circuit in form of heat. So if we use this formula I square R, we can say that if we want 16 joules of energy, we must have 4 amperes of current and 1 ohms of resistance. So that 4 square is 16, and 16 times 1 is 16 joules per second. Alright, so the correct option is, we can go with option D.